Hey everyone, my name is Josh Kroenke. Yeah, just like the owner of the Denver Nuggets. But I'm not into basketball or management, and I'm definitely not a billionaire. What I do know is cars, and that's exactly what I talk about on this channel. Alright, enough with the intro. Let's get into today's topic.
As with other electric vehicle technologies, axial flux motors are not exactly a new idea. The idea was already taking shape at the hand of Michael Faraday in the early 19th century. However, one person can largely be thanked for the renewed interest of the automotive industry, Dr. Tim Wormer. Importance of the axial flow motor. However, the idea of mass decomposition is really what pushed him toward axial flow designs. At least on paper, the new configuration promised a 30% size reduction compared to a similar power radial flow, as well as considerable weight savings. That percentage is much more significant than you might think, especially in 2- or 3-motor electric vehicles. If we can get 100 to 200 kilograms out, you're starting to really influence your vehicle. The axial flow motor is very good conceptually, but it is more difficult to mass produce compared to the radial flow motor. In addition, there are many configurations of axial flow motors, so Dr. Wormer had to determine which one was best to develop at scale. He landed on the YSA configuration in the late 2000s after becoming interested in a material called soft magnetic composite, commonly known as SMC. Instead of stacking laminations, you can press it into a three-dimensional shape with fairly simple tools. This has many advantages in terms of construction and motor efficiency, but there is one limitation: you can only make parts that are, at most, the size of your hand. This is due to the immense pressure needed to compact SMC into a solid form. Rallying believers as expected, Dr. Wormer was met with much skepticism. He says early conversations with investors went something like this: there are no electric cars. There is no market for your product. Even if there was a market, and even if you started selling your technology, you would just lose money, and it's going to be a disaster. This did not discourage YSA enough to stop. Shortly after its founding, it got its first big break by building engines for the Jaguar CX-75 concept in 2010. The unorthodox turbine-powered hybrid electric supercar never made it into production, although it made a splash in the 2015 James Bond film Spectre. Then it supplied YSA engines for the $2 million Koenigsegg Regera plug-in hybrid electric supercar in 2015, the first production vehicle to feature its technology. Then came orders from Ferrari and McLaren before Mercedes bought the company, though it is still working with outside partners. Even so, by 2023 there will still be no mass-market axial flow electric vehicles on the market. The real opportunity in the pure electric vehicle space has yet to be seized, but Dr. Wormer says it's only a matter of time. More than anyone else in the auto industry I've talked to, on the record, about the future of enthusiast cars, he understands that it's not just about how fast you can get to 60 miles per hour. There's been a bit of a benchmark: everyone build an electric vehicle fast, he said. This turned out to be fairly easy to do. We can see a number of fast, heavy machines from companies like Tesla, General Motors, and more. But now, the mentality has changed. Everyone has recognized that they are fast. Now the next change is how to make them more attractive, how to make them more fun. The ultimate goal: doing so will require reducing weight to the realm of sanity and using energy more efficiently rather than simply cramming more battery cells into a car. That's exactly what axial flow motor technology enables. As batteries get better, architectures get optimized, and the weight of subcomponents decreases, there's no reason why they can't be lighter than IC-powered cars, says Dr. Wormer. Electric cars: 7 electric vehicles worth waiting for in 2024: Prius, Prime, GMC, Hummer EV, SUV, Tesla electric car charger. In conclusion, understanding how today's electric vehicles work reveals the impressive technology that powers them. From the efficient electric motors to the advanced battery systems, these vehicles are designed for performance and sustainability. As we continue to innovate and improve these technologies, electric vehicles will play an increasingly vital role in reducing our carbon footprint and shaping the future of transportation. Thank you for watching, and we hope you gain valuable insights into the world of electric vehicles.